Welcome. In this video we are going to focus on using recursion to do things other than draw pictures. So recursion is a nice tool for drawing those fractal shapes, but it's also a general purpose problem solving tool. Basically any problem where we might normally use a loop, we can replace that with recursion. Now it may not be as intuitive or as easy, but we can always do it. And it turns out that there's some problems where the recursive version makes more sense and is simpler to write, and others where the iterative version, the version that uses an explicit loop, is easier to deal with. So we're going to start by just looking at this script that I've already got built. Say the number is from blank to 0. If I click it, we get 4, 3, 2, 1, 0. Right? Does exactly what it says it's supposed to. We obviously could build this script. So if I wanted to count down from 4 to 0, right, we could build this with a loop. I could repeat 5 times, and I could make a variable called number, and I could set the number initially to be 4, and then I could change the number by -1 as I go through this, and as I repeat this process I could say the number. So we'll set the number to 4, repeat 5 times, say the current number, subtract 1, do it again. Alright, so this would be the iterative solution, the solution that uses an explicit loop that says repeat this 5 times. And obviously we could adjust this. Instead of repeating 5 times, I could do repeat number plus 1 times to make sure we get all the way down to 0, and that way it'd be a little bit more flexible. All right, but I could build this say the numbers block using code pretty much just like that. But that's not how it's built. Here's the actual code. And I'm going to turn off number. So how do we say the numbers from n to 0? Well, if n is less than 1, we say 0, and we could easily rewrite this. If n is 0, we say 0. The less than 1 just is make sure if we put in a negative number we don't blow this thing up. But so if we hit 0, we say 0. Otherwise, we say the current number, and then we say the numbers from n-1 to 0. Right? Very similar to the technique we used in the tree and the snowflake. But the basic process is, so if I say the numbers from 3 to 0, this says, oh, are we less than 1? No. Okay, so we're going to say 3, and then we're going to say the numbers from 3 minus 1. Well, that's 2 to 0. And so we basically go run a separate version of the function that does it with 2, and no, we're not less than 0, so we say 2, and then we got to do 2 minus 1, so now we've got to say the numbers from 1 to 0. Well, we're not less than 1 yet, we're not down to 0, so we say 1. Now we say the numbers from 1 minus 1 to 0, which basically means, hey, go do this again, but now using 0. Oh, 0 is less than 1, so we'll say the 0. And then once we're done doing this work, we go back to wherever we came from. So we come back to say the numbers from 1 minus 1, and we're done there. So we go back to where we came from, which finishes that up. And so now we can go back to the original version. And now we can finish this version and go on with the rest of our program. This is how the recursive version works. It keeps making new calls to the same function using smaller and smaller values until we finally bottom out in that special base case. And then we kind of unwind things and get right back to where we were. So we saw this count successfully. I'm going to make one tiny change. I'm going to move say the numbers from n-1 to 0 before the current say. And we're going to run this version. So say the numbers from 4 to 0, 0, 1, 2, 3, 4. Before he was counting down, and now he's counting up. Right? Now this name doesn't make much sense. It should say the numbers from 0 to blank. But we've changed the behavior by changing the order of those two steps. So this is the recursive step, the step that says go off and do the problem again, only with a smaller number. Say n, this is the current step. If I'm on 4, this is what says 4. So the original version says say 4, and okay, now go do it for 3 on down to 0. And then the 3 one says, okay, say 3, oh, now go do it for 2 down to 0. Right? By changing these, we change the order in which those things happen. How do we do 4? Well, we go off. Right? If I say, or how do I do the 3 version? Well, I'm not done yet, so I go off and do the 3 minus 1 version, the 2 version. Okay, how do I do the 2 version? Well, I'm not done yet. So, first I go do the 2 minus 1, I go do the 1 version. Okay, how do I do the 1? Well, I'm not done yet. So first I go 1 minus 1, and I go say from 0 to 0. Okay, now I'm at 0. Oh, good. We're done here, so we'll say 0. And then we're finished here. There's nothing else to do down below the if-else. So we just return. We come back to where we were. So in the 1 version, this is the point at which we went off and tried to do the 0 version. So we're done with the 0 version. So now it's okay to say the 1. And then we're done with the 1 version. So we can bounce back out to the 2 version. And right here is the point where we went off to do the 1 version, and we did that, now we're done. So now we say the 2. And once that's done, we can bounce back up to, okay, we're done with the 2 version, which is what that said. So now we can finally say the 3 and the 4 and the 5, and we're basically saying the current value after we've gone down that chain and said all the numbers that come before it. And that's how we get the counting up process, just based on kind of which order we're doing these 2 steps. Now, we don't have to just say things. We can also kind of capture the results by adding the current value to the ones that come before that. So we're going to go build a reporter that adds up all the numbers from n down to, we don't need 0, because that's never going to affect anything, from n down to 1. Alright, so let's go make a block, and it'll be, might as well call it an operator, a reporter, add numbers from %n to 1. And remember, the %n is just automatically going to put in a little parameter for me, so I don't have to do that by hand. Okay, so how do we add the numbers from n to 1? We need to come up with a recipe. And our recursive recipe is always got to have those 2 cases, the if-else, the base case and the general case. So what the base case should be our simplest possible thing. What if n is 1? Right? What if I'm asked to add the numbers from 1 to 1? Well, that's pretty easy. That's just 1. Okay, how about if I'm asked to add the numbers for anything bigger? Well, here's how we could write mathematically this process. So the sum for numbers n down to 1 we'll define as, if n is equal to 1, then it's just 1, right? Just 1's our only number. If it's bigger, well, the way I can figure out the sum is to take the current number plus the sum of everything less. Right? How do I do the sum of 3 down to 1? Well, I take 3 plus whatever 2 and 1 are. Well, how do I do 2? Well, I do 2 plus whatever 1 is. How do I do 1? Oh, well, that's defined for us. We know that's 1. And so then we can kind of work backwards and say, okay, well then, if 1 is 1, then 2 must be 2 plus 1, which is 3. So then we know the information for 3, which must be 3 plus the 3 that we've already got. We're basically doing this version where we're chaining down till we find a place where we know we can stop. And then as we come back out, we're going to add each of those values to to our current number. All right, so let's start building this. I know I need an if-else. I know my kind of finishing case, my base case, is going to be what happens if I'm asked to add from 1 to 1. Right, I get all the way down to 1. I know the answer is 1. And so since this is a reporter, I want to make sure I report the answer. All right. Great. The answer is 1. If it's not 1, right, if I'm in the other case, then the recipe I want to do is the current number plus everything down below this one. So to write that, right, I want to add the current number, whatever it is, plus all the numbers from n minus 1 down to 1. All right, so this is where the recursive call comes in. How do I do n? Well, I'm going to do the same thing, but I don't want to do it with n. I want to do it with n minus 1. Come here. So put in the n minus 1, and we're going to add that to the current number. All right. So I'm going to put in the final report. All right, and so this should do the trick for us. We're going to kind of watch it run, and then we'll come break it down and look at it a little bit closer, how it's doing its job. So under operators, here's my new block. So if I add the numbers from 3 down to 1, 1 plus 2 is 3, plus 3 is 6. And great, I get that. If I go from 4, it should be 6 plus 4 is 10. Good. If I do 5, it should be all those. The 10 plus 5 is 15. Okay, if I do 6, it should be that 15 plus 6 more is 21. Looks like it's working fine. And that basic logic of, well, how would I do 7? Well, I know that 6 was 21, so 7 must be 21 plus 7 more. That's basically the logic that we're doing inside here. All right, if we put some says in, I could, hey, say I got down to 1. The else, I could say, let's actually put a join in here. I'm at, and we'll put a space in, and then we will have him say the current number. And then I'm actually going to duplicate this. Oops, I just want that one block. So I'm at n, and I'm going off to do, and then what I want to do is the n minus 1 is what I'm going off to do. So we're going to put something like that. So he's just saying what he's doing, what he's thinking as he goes. So how does he do 7? Well, he looks at 7 and says, oh, I've got to go off and do 6. I'm at 6. How do I do that? Well, I go off and do 5. I'm at 5. Okay, how do I do that? I go off to do 4. Until he finally gets all the way down. Our actual answer is all happening kind of with the result of doing this add numbers from. So in order to be able to see what's happening, we have to take this outside the report. So I'm just going to go make, let's actually do this with a script variable. I'm going to call this total so far, and we will set total so far to be the result of adding the current number plus doing the recursive call where we go add up all the numbers less than this one. And by having it in the variable, that means I can say the total so far and then report it back. All right, so we'll see that he's not going to start saying his total. And actually, let's put a join in there just to make it a little bit clearer. So he's not going to start saying his total until he gets all the way down and starts coming back out. So I'm going to make this a little quicker. We'll do it from 3. So he's at 3. How do I do 3? Well, I got to go off and do 2. I'm at 2. How do I do 2? I got to go off and do a 1. okay, I got down to 1, so that's 1. So 1 plus 2 is 3, plus 3 is 6, and so our final answer is 6. We get the totals as he comes back to each level. So if I do, I'm back at n, make it even a little bit more clear, and let's do it one more time going from 4. So he's at 4, he goes off and does 3, then he does 3, goes off and does 2, he goes off at 2, he goes off to do 1. Finally he bottoms out and says, okay, we got to 1, so the answer is 1. We come back to level 2 and say, okay, 2 plus 1 is 3. Okay, so now we go back to level 3 and say, 3 plus 3 is 6. And now we're back at 4 and say, okay, 6 plus that 4 is 10. And there's our final answer. Okay, and as a final step, let's clean this up. So here's my block. Alright, I've put a lot of extra stuff in there, just doing the says to kind of watch what's going on. But the actual recipe was amazingly simple. Alright, so let's strip back down to that. I don't need the script variable at all. So if the number is 1, then I just report my answer. The sum is 1. Otherwise, well, once again, I don't need the says. I don't even need the total so far. Right? I know that what I'm going to report is the current number plus the sum of all the numbers from n minus 1 down to 1. Right? So I can get rid of all that stuff. The only reason I need things like that is to kind of help see what's going on. And here's the recipe that actually does the work. From 4 to 1, you sum all those up, you get 10.